Okay, welcome everybody. I think we're gonna get started now. So hello, welcome to the GE Healthcare breakout room. We're gonna go into a little bit more depth into our project and have some time at the questions at the end from anything you saw in this presentation or the first presentation we showed earlier. So thank you all for being here. So to start out, we're going to do a quick reminder of the actual problem that we worked on this semester. We were developing an intercom system to facilitate communication between a patient in a CT machine and an operator in a different room who is carrying out the scan. Our intercom was able to filter out noise in the background of the CT scan so that the patient voice could be heard clearly. And then from the operator to patient side, we wanted to facilitate communication so that the operator could communicate crucial instructions to the patient in order to properly carry out the scan. So a bit about our process. We divided up our work into a series of short sprints, which are essentially 2-week periods in which we have some concrete goals that we want to accomplish by the end. To begin the year, we spent a few sprints on research and looking into different types of noise cancellation algorithms and seeing which ones were most applicable to the project and that we would want to move forward with. After that, we moved into simulation, in which we simulated some of these noise cancellation algorithms purely in software with some pre-recorded audio sounds to see which ones were most successful and how they compared against each other. From here, we took the most promising noise cancellation algorithms to our implementation sprints, in which we implemented these various algorithms on a development board, like a plug and play piece of hardware, which enabled us to do some actual real-time testing. And then finally, we ended off the year creating a live test setup, which we'll talk about in a bit, and evaluating the algorithms that we implemented to provide feedback and next steps to our liaisons at GE Healthcare. Regarding the noise cancellation, we decided to go forward with an adaptive filter. An adaptive filter is essentially a filter that is able to differentiate between the patient voice and the noisy environment in which the patient is being scanned. And most importantly, it is able to adapt to the environment and continuously cancel out noise as it changes. For example, the patient might be moving around. The gantry itself might be making a few different noises. There might be people walking around in the background, and an adaptive filter is able to change and continuously cancel out the noise. This filter is modified in real time by an optimization algorithm, which we implemented on our plug and play hardware. And this optimization algorithm is done based off of a primary input and a reference input, which are shown in the very general schematic on the left here.
So as you saw in our snapshot presentation, this is a picture of our testing setup. And we'd like to share a few audio files with you now that we collected from some simulations as well as from this setup. So for these samples, the inputs to the system are first a recording of CT gantry noise that we received from our liaisons at GE Healthcare. And then the other input is a simulated patient voice, which is actually me talking, saying Harvard sentences, which are sentences that are widely used in audio intercom testing because they are phonetically balanced for the English language. So for this first sample, this is the live test setup that I just showed you on the previous slide without any algorithm running. The audio is just passing through the system to show you what that sounds like. The birch canoe slid on the smooth planks. Glue the sheet to the dark blue background. And in this next recording, this was an entirely simulated test. So the noise cancellation algorithm is running on a computer and the inputs are digitally put into that system. So this is entirely simulated with the algorithm to just see the algorithm itself. The birch canoe slid on the smooth planks. Glue the sheet to the dark blue background. And then finally, this last audio sample was collected from the live test setup, again from the previous slide. The birch canoe slid on the smooth planks. Glued the sheet to the dark blue background. So after listening to those samples, you may have noticed that the last recording from the physical testing setup with the noise canceling didn't sound quite as clean as the simulated version. And after doing some further testing and evaluation, we came up with a couple of hypotheses about why this might be happening. The first one is that, as I mentioned, the two microphones need to pick up two different signals. One of them is just the noise from the gantry, and the other is the patient's voice mixed with that noise. If the patient's voice starts to show up in the first microphone, this can cause the patient's voice to start to be canceled out, which could create that robotic effect that you heard. And this might be if the microphones are too close together or if they're not well enough isolated in the test setup. Another hypothesis is that we added these speakers to emulate the testing environment instead of having a real gantry and real patient speaking. And that kind of expanded the system and made it more complex than we had originally thought of. And so that could be another reason why the output is a little less clean in the live testing setup. And these results we collected show that this algorithm may have potential to cancel out CT machine noise, but some further testing is needed with future iterations of the live test setup.
So as we mentioned in the snapshot, we also wanted to think carefully about how mechanical enclosures will affect this intercom system. And one important enclosure is the box which contains the intercom system on the operator's desk. And this is what they actually use to interact with the system. And we prototyped this semester with a 3D printer and actually constructed a physical object here, which we're able to use for testing. And in designing and developing this prototype control box, we, through conversations with our liaisons, determined some important design guidelines. One being that it's quite similar to some previous versions of this control box physically. And so this familiar interface, not having to learn something new, was important. This as well as the actual tactile interface, turning knobs and pushing buttons rather than using a touch interface. And of course, because this is a part of the intercom system, we want to make sure that the audio played through the device and then the reception of audio through the microphone is clear. And finally, we wanted to actually extend this to prevent water from getting passed into the box in the event of spills or cleaning with water as well. So in the next slide, we can just think in context of what we ended up with. We made an integrated prototype, which we can give to GE Healthcare, which is going to be a great platform for further optimization and refinement. Maybe we'll think of some other algorithms to try, and this test setup will be a great way to actually test those out. Additionally, the electrical hardware which we used, as it gets modified to custom hardware for the final product, will be guided by our process as well. Moving forward, some tests on actual CT gantries will be important. Due to COVID-19 limitations, we weren't actually able to go into hospitals and test this out, but in the future, this will be important and useful. We also didn't talk in detail about this, but we did study in some depth the effect that mechanical vibration of the microphone mounted on the CT scanner had on the audio quality, and this is another thing we took a look at. On the next slide, we just want to give a big thank you to GE Healthcare and their liaisons. They supported us a lot through this project and helped us get to the point we did. So we want to not let that go unnoticed, as well as all the support we got from our Olin faculty. So we have a little bit of time now to ask questions, anything that you are curious about, which came up along the way. Here are some ideas for questions if you have need some prompting or anything, and we can of course go back and look at the slides if we need to do that as well. But thank you for listening, and yeah, feel free to unmute and ask any questions you have.
Feel free to type your questions in the chat as well.
A quick clarification question. Was this wireless or was it hardwired?
That's an excellent question. Actually, one of the design constraints was that it had to be a wired system because hospitals have a lot of RF noise going on, and so it's entirely wired. Yeah.
Okay, thanks.
For the question, what was the most challenging part about doing this remotely besides not being able to test it in a real hospital environment?
Who wants to answer that?
Probably that we were trying to like make one like holistic system, but we had a lot of people in a lot of different places, so it was difficult to coordinate like shipping or like remote, like getting parts that were made in two different locations to like fit properly and work together properly without designing them in the same space.
Yeah, just to add on to that, it was also sometimes tricky working with hardware and trying to debug firmware that's running on the physical system like remotely. Jonah off campus had one of the like development modules at his desk, and there were a lot of Zoom calls where various people were like on camera looking at Jonah's shared screen and then like taking a picture of an oscilloscope with waves. So that was another challenge.
Also, like working on an audio project while you need to be on a call that uses audio is pretty difficult. There were a lot of speakers and cables and headphones and interference and feedback.
Lots of unplugging headphones, saying, okay, sorry, I can't hear you for a little bit, plugging in the dev board to like listen to what sound it was making, unplugging it, plugging back into headphones and explaining what was happening. It was great.
So the
I guess I have a
consideration.
question. Oh, go ahead.
Oh, I'm sorry. The consideration of the noise canceling piece of it, you know, in a regular hospital room, you would have lots of different areas to mount the microphone to see what the CT system, because every CT system is a little bit different from a noise standpoint. Did you consider where you would be mounting some of these things? And then I know you talked about a little bit about the isolation from the actual patient. Did you consider like where the most optimum spots would be with regard to this these noise canceling microphones?
I think that's something that we definitely hope to have spent more time on. We did, because of the way the algorithm works, we are constrained to putting one microphone in a place that mostly just picks up the noise of the gantry. And so with talking with liaisons, we thought that that might be somewhere inside the gantry itself. And then we need another microphone that would be picking up mostly patient voice, but that would also be hearing some of the gantry noise. But beyond that, I don't think we really had time to optimize for that, but that does narrow it down a little bit.
It would be nice to like be able to test on an actual gantry that we're able to work really closely with, because we did have some brief discussions about like maybe like the problem that Vienna was talking about regarding like a microphone picking up something that it shouldn't be picking up. Like we were talking briefly about potentially embedding one of the microphones like within the gantry, or doing a more creative arrangement that like our on-campus test setup really didn't have high enough resolution to test accurately. So that would have been a really cool thing to do if we were able.
Yeah, it's too bad this COVID got in the way. It could have been really neat to see that.
Can you talk about your future testing ideas? And I'm also curious what GE would like to see. Like, are they going to implement this, and what are the plans with your project?
Yeah, I think like some of the future testing ideas we had were, I think it would probably be pretty important to test it on like an actual gantry, like we said. And because we had to approximate like the noise source with a speaker. So like getting an actual gantry to make actual noise would be pretty useful. And I think in terms of like a future steps that you're asking about, I think we had talked briefly as a team maybe that a useful step would be like a more electromechanical solution to the problem. like creating hardware that would help in noise cancellation. And also, I think they were talking briefly about using like machine learning techniques to eliminate the noise as well. Anyone else feel free to chime in.
Yeah. To add on to the part about the testing system, I briefly mentioned earlier that we were playing the gantry noise in the patient's voice out of speakers. And then we were just recording the output of the system, like all the way at the other room on the operator side. And so it would be helpful to insert a couple more like measurement points so that we could record more audio throughout the system, and like isolate just the development module where the algorithm is running and listen directly before and directly after.
Okay, great. And what about GE? Can you elaborate more on what their plans are?
I think honestly, we are not completely in the loop as to where we're planning on taking this. I think our understanding is that at this point, they are going to take what we've learned and ideally pass it on to a team that will be able to do more in depth and better, with a better testing analysis of where we're at. Yeah.
Yeah, I'm sorry, I'm with GE, but I don't work on the CT system specifically. It would have been nice to, if with regard to this COVID stuff, is that we have full labs here that do noise measurements and look at all this kind of stuff. And it would have been nice to have you there and having a CT system in that room and being able to do some actual power measurements of your noise for a CT system and coming up with maybe an, if you will, an average kind of a noise cancellation algorithm, using some sort of a bandpass filter and comparing it to the actual human voice frequencies and stuff. So that would have been really cool. But unfortunately with the COVID, it wasn't to be. So
Yeah, our liaisons this year were super helpful in taking measurements for us and sending them over, but it would have been super cool to be able to bring our actual prototype over and test it on an actual setup.
And this is Adam from healthcare. And I think, yeah, I know we were talking about having all the parts shipped back. So I think we still can do that. And we'll try to follow up with you guys if we're able to do that.
You're going to get them. They're coming.
Okay.
This morning.
Yep. With that, I think this is our time for to switch rooms. You're welcome to stay for another round if you would like to hear our presentation again and more questions. But otherwise, I think it's time to switch.
Thank you. Good job, you guys.
Yeah, thank you. Nice job.
Everyone.
Everyone.
Thank you for coming.
Thank you, everyone.
Thank you.